Hello viewers, good morning and welcome again to Esomnofu online math class. In this video, we are going to discuss the nth term of an arithmetic progression. Kindly hit the red button to subscribe to my channel. It gives you notification whenever a new video is out. So, speaking on the nth term of an arithmetic progression, it is just a general formula we use to get the various terms of a given sequence. When you come into arithmetic progression, we can have so many terms like 3, let's say 5, 7, 9, etc. This is the first term, the second term, the third term, the fourth term, etc. There are several other formulas that follow. Okay, there are several other terms that follow from here. You can continue to have 9, 11, 13, 15, etc. Okay, so what if you need the 100th term? Are you going to be adding 2 till you get to 100? You see that this will take you a lot of time. Consequent to that, we have what we call the nth term of an arithmetic progression. This nth term will help you to get every other terms you want to get. Generally, in an arithmetic progression, there is a formula we use to get the nth term of an arithmetic progression. We say that Tn is A plus bracket n minus 1d, where the A is the first term, n is the number of terms, and d is the common difference. This particular nth term formula is for every sequence, but if you want to get a peculiar formula for a particular sequence, you can from this nth term derive the formula. So for example, today we are going to get the nth term of this particular sequence here, where we are having 3, 5, 7, 9, etc. First of all, you have to know that the first term of this sequence is 3. The first member you are seeing there, it is 3. So you write 3, our A is 3. Our common difference is just second term minus first term, or third term minus second term, or fourth term minus third term. In each case, you get a common number. That is why it is called a common difference. So the common difference is 2, because if I add 2 to 3, I'll get 5. If I add 2 to 5, I'll get 7. If I add 2 to 7, I'll get 9. Of course, n remains n because we are looking for the nth term. Therefore, Tn for this particular sequence will now be, seeing A here, I'll plug in 3 for A, plus bracket, n will still remain n minus 1 into d. D is the common difference, which is 2. So have that Tn equals 3 plus, these 2 will go into the bracket. 2 times n is 2n. 2 times negative 1 is negative 2. You can collect like terms by saying 3 minus 2 will give us 1. So Tn is equal to 1 plus 2n. Okay? Now, from this formula, 1 plus 2n, which is now the general formula for the nth term of this particular sequence, you can use it to get every other term we want to get. For example, look at the first term here. This is the second term, third term, and the fourth term. Okay, so assuming I don't know this fourth term and I want to get the first term, it means that wherever I see n here, I will put 4. When I put 4 here, I must arrive at 9. So you can now see that T4 is now 1 plus 2 bracket 4, which is giving me 1 plus 8, because 2 times 4 is 8, and when you add up, you are getting 9. Have you now seen this 9? So this nth term is just a formula that can be used to get various members of a given sequence. So if I still want to get the 100th term of this sequence, I'll just write my Tn is 1 plus 2n. That is the general formula of this sequence. Okay, so if I now want to get the 100th term, instead of wasting my time to be adding 2 till 100, I'll just plug in 100 wherever I'm seeing my n. So T100 will give me 1 plus 2 times 100 is 200, and 1 plus 200 is 201. So the 100th term of this sequence is 201. Okay, so at this point, there are other arithmetic progression whereby they are not increasing at the same rate. Like here, they are increasing by the addition of 2, 2, 2, 2, 2. I will give you another sequence here whereby the common difference does not tally in each successive terms. Okay, so assuming we are given this arithmetic progression, or not even arithmetic progression, but a progression, and we are asked to get the nth term of this particular sequence. If you look carefully here, you will see that I added 11 to 7 to get 18. I added 15 to 18 to get 33. And I added 19 to 33 to get 52. So you see that what I'm adding in this case is not similar. Okay? Different numbers are added to every term to get the one next to it, which is unlike the first one we discussed. So if I were you, look at the thing you do. First of all, let's get the first difference. The first difference between successive terms. Difference between 18 and 7 is just 11. Difference between 33 and 18 is just 15. And the difference between 52 and 33 is around 19. So the differences are not common. So continue to get the difference until they become common. Okay? So you have your second difference. 15 minus 11 is 4, and 19 minus 15 is 4. So you see that at this stage, we got the same number. So since if you go 2 times to get the common difference, it means that this is a quadratic sequence. So we are going to use quadratic rule. We are going to use quadratic rule to get the nth term of this particular sequence. If you go 3 times to get it, it means you are using cubic rule to do that. If you go 4 times, and so on and so forth. So, but since we've gone 2 times to get the common difference here, we use quadratic rule. And the quadratic equation is of the form an squared plus bn plus c. Okay? That is the form of arithmetic progression. So, for the first term now, let's say tn, my t1 from this formula will be a bracket 1 squared plus b bracket 1 plus c. So t1 will give me 1 squared is 1, 1 times a is a, b times 1 is b plus c. This is my t1. My t2 will be, I'll put 2 in the same formula. I'll have a into 2 squared plus b bracket 2 plus c. So t2 will give me 2 squared is 4, 4 times a is 4a, plus b times 2 is 2b, then plus c. t3, let me continue. You can go as much as you want, but I will stop at t4. t3 means putting 3 in the same formula. I'll have a into 3 squared plus b into 3 plus c. So t3 will now be 3 squared is 9, 9 times a is 9a, 3 times b is 3b, then plus c. If you like, go one more, t4, I'm putting 4 in the formula. So I have a into 4 power 2 plus b into 4, then plus c. So t4 will give us 4 squared is 16, 16 times a is 16a, b times 4 is 4b, then plus c. So you successfully got the first term, second term, third term, and fourth term of this particular sequence. So let us arrange them properly. I'll clean this. The sequence we have is 7, 18, 33, and 52. Okay, and our first difference is when we subtracted here, we got 11. Here we got 15. Here we got 19. But we subtracted here, we got 4 and 4. They are similar. So now the first term I got, my first term T1 is A plus B plus C. That's my first term. My second term is 4A plus 2B plus C. My third term is 9A plus 3B plus C is 16A plus 4B plus C. That's my fourth term. Okay, so let me get their first difference. First difference, just like I did here, this is the first difference and this is the second difference. This is the terms of the sequence given to us. Fourth difference saying this minus this. And to do that, 4A minus A will give us 3A. 2B minus B will give us B. And C minus C has gone. The other difference, 9A minus 4A will give us 5A. 3B minus 2B will give us B. And C minus C has gone. This difference, 16A minus 9A will give us 7A plus 4B minus 3B will give us B, and C minus C has gone. This is the first difference. Let us get the second difference. You say 5A minus 3A will give us 2A. B minus B has gone. 7A minus 5A will give us 2A, and B minus B has gone. So you see that at this stage we are getting the same number, 2A and 2A. Therefore, coming here, you should know that under the second line here, we have 2A as the first element there. Under the second line here, we have 4 there. So I can say that this and this are equivalent. Therefore, I can write that 2A is equal to 4. Divide both sides by 2. My A is now 2, because when I divide 4 by 2, I'm getting 2. Also, if you move up here in the first difference, I have 3A plus B. In the first difference here, I'm having 11. Therefore, you are not wrong if you write that 3A plus B is equivalent to 11. But our A is 2, so you plug in 2 for A. You now have 3 bracket 2 plus B is 11. 3 times 2 is 6 plus B is 11. So B is now 11 minus 6. So B will give us 5. Also, if you move up again, we have A plus B plus C, and we have 7 here as the first element there. So you can say right that A plus B plus C is equivalent to 7, is equal to 7. My A is 2, my B is 5, and my C is what I'm looking for. So 2 plus 5 is 7, plus C is 7. So C is now equivalent to 7 minus 7. So C is 0. Okay, so now I'll clean it. General form Tn for quadratic sequence is an squared plus bn plus c. Already my A is now 2, so the Tn becomes 2n squared plus my B is 5. We have 5n, and my C is 0, then plus 0. But 0 is nothing. Therefore, the n term of this sequence given to us is 2n squared plus 5n, and that's just the answer, the n term. Whenever the sequence is a quadratic, it takes a lot of time to get it, and this is just the answer. So let us test if we are correct. Let's look for this 52, and this 52 is number 1, 2, 3, 4, the fourth term. So let us put 4 here to see if we can get 52. Okay. So T4 will give us 2 brackets, sin n, I'll put 4 squared plus 5 bracket 4. So T4 is now 2 bracket 4 squared is 16 plus 5 times 4 is 20. So T4 is now 2 times 16 is 32 plus 20. And 32 plus 20 will give us 52. So we are in order. This is now how to generate the nth term of an arithmetic progression when it is a quadratic. In the next video, we are going to discuss how to get the nth term of an arithmetic progression when it is a cubic, when we go into 3 places to get the common difference. Okay, so thank you so much for watching. Kindly hit the red button to subscribe to my channel. It gives you notification whenever a new video is out. Thank you so much.